All right, welcome back to another video. So we're on a quest to get every loopback to be able to ping to every other loopback, but we can see we've got the routers in different BGP autonomous systems. So far we're still working on the first router, Biloxi, but we've made lots of progress. It can ping Memphis, Jackson, Miami, and Atlanta. So let's see if it can configure, if it can ping Topeka. So can't ping Topeka, no route to host. So let's figure out what the issue is here. We know that the issue is that it's got no route to host. So it's very clear that the policies on Jackson are going to need to be changed. But the good news is they're going to mirror a lot like the policies in Memphis, which we have. So we can just simply modify what was applied to Memphis and apply it to Jackson. And it'll be a lot easier now that we know more of what is required. All right, so here's the configuration from Memphis. So we're going to need to make configuration for both IBGP and EBGP. So I'm going to put all the IBGP configuration together and all the EBGP configuration together. And then, of course, we are going to need that next hop self as well for the IBGP routes. We won't need it for the EBGP. So here they are, but clearly we're going to need to change a few things. We're going to need to change the neighbor, and we're going to need to change the routes. The neighbors are already configured, but of course I don't have the kind of naming scheme that I want to have. Well, actually, it looks like I do. I have, yeah, it's named the same. So I won't need to reconfigure the neighbors. That's already done. And then I also won't need to reconfigure the autonomous or the type and the peer AS. That's completed. So all I need to worry about is the export policies and the route filter lists. So okay, so really then all I really need to worry about is these routes here. So let's figure out what those are going to have to be. So we're going to need to allow all of these routes, and these are going to come in and be learned through IBGP. So we've even got to include those routes. So we're going to have 1, 2, 3, 4, 5 routes that we're going to export into EBGP, but only one route we're going to export into, only 2 routes. This one and this one we're going to export into IBGP. So let's go with the easier one first, because we're only going to need 2 routes to go into IBGP. It's going to be 172.26.4.0/22. And then its own loopback needs to go in as well. 68.0.0/16. Perfect. So now got a lot of routes we're going to need to add to EBGP, and you can see, as I mentioned in the last video, just how impractical it becomes to actually have a route filter list for the routes that you want into BGP. You really got to use a different method, like bringing in all the routes from a particular protocol, for example, direct or something like that, or matching the routes based on their community string. That's going to be a much more scalable way of exporting routes. Just statically defining which ones you want exported. It's going to work if you got a lab like this, especially where you don't have any IBGP multi-hop IBGP connections. But something like this, it's not going to work, or it is going to work. But something more complicated than this, it won't work. Okay, so keep my eyes on the prize here. And I think kind of the key to the test, because I'm going to be doing, I think, a lot of this sort of thing during the test, is getting it right the first time. Because if you go in and you do it wrong, you've got to spend that time troubleshooting, and that can be a lot of time. And you can even see right here, I did a 2.7 instead of a 3.7. So what I like to do is just go back over it once and double check before I continue. Because getting it right the first time is going to be a lot more time efficient than having to go and troubleshoot. So even though it'll take a little bit longer to configure it initially, you might end up saving yourself a full hour down the line than if you hadn't done that check. All right. Oops, come on. There we go. Yeah, that's something I'd like to do in future videos, is just, you know, for the purposes of learning, just string up a management network and then do all my configurations over that kind of fake management network. Because just doing console like this, it's really kind of a not real world scenario, because are you going to walk to every single router, plug in your laptop and console into it? Well, no, but essentially that's what I'm doing here in the lab. So if instead I just string up a management network and do everything through that, that's going to be a lot more realistic. So let's see here. Now I'm going to do show pipe compare, and it's going to give me a lot better practice too. Oops, so let's see. Aha, so it looks like I forgot to remove where this was called. Yep, so it's still being called here, so all I gotta do is delete that. And now, hopefully it'll commit. There we go. And before I do anything else, I'm going to add the policy to Topeka. And Topeka is only going to need a into BGP policy. Oops. All right, so looks like it's already got, oh yeah, this is the only policy it's going to need. So this is actually already set up. I can, of course, change the naming of it. I think I'll do that actually. And it looks like it's not being called in the BGP group or under the neighbor or to BGP, the whole protocol. So I'm going to have to do that as well. So edit policy options, show pipe display set relative. And now I'm going to delete policy statement into BGP. And then I'm going to, let's see here. Oh, I kind of wish I would have done that differently, but that's okay. So now I want to uppercase all of these and have it be into EBGP. Perfect. All right, so now hopefully this Biloxi is going to be working. Oh, we still got no route to host. So let's take a look at, well, okay. Well, maybe did I have the next hop self on Jackson? I thought I did, but let's set up show configuration, or we're gonna do a show BGP summary, of course. And now show BGP, oh no, show route, receive, protocol BGP, and then the neighbor is going to be 10.2.2. or 10.10.2.2. So you can see I'm only getting this one. I'm not getting the other two. Well, let's see if they're hidden. And they're not even hidden. So I'm just straight up not getting the route from Topeka for some reason. So let's figure that out. Show route advertising protocol, BGP. Oops. Show BGP summary. And now the neighbor, so it's going to be 10.10.2.1. So yep, you can see I'm only advertising this route. I'm not advertising the other ones, which is interesting because I thought I just applied the configuration to advertise it. Is it missing or something? I don't understand why. So 172.26.4.00, so there it is. And then there's into BGP there. So yeah, you can see very clearly I am advertising it, so I must not be receiving it. Show route. I must not be receiving it from Topeka. We'll see if that's the case. So sure enough, I'm not receiving it unless it's hidden. Nope, it's not even hidden. So yep, there's a problem on Topeka where it's not able to send out that route, which is interesting because show rollback, show system rollback, compare 1.0, because you can see I added it, but let's see what actually got on there. Aha, so you can see I never applied it to the BGP group. All right, so hopefully that solves the problem. Perfect. So now it's working. So I'll do a victory lap and I'll just ping every single one. And then I'll move on to Memphis. So 10.242.152.1. Perfect. 172.28.37.1. Perfect. And just as an aside here, so I only advertised those loopbacks into BGP. So if I were to ping these interconnect addresses, 10.240.10.1, I'd have no route to those hosts because I did not advertise those subnets into BGP. All right, time for Memphis. Perfect. I can ping myself, so I'll skip over to Jackson. Perfect. And final lap, Topeka. Perfect. Okay, so I'll cross off this router here. All right, and now let's move on to the next one, Memphis, and make sure that we can ping every other router. And this will be interesting because my intuition tells me that you would not be able to. You'll need a little bit of extra configuration in order for that to be possible, but I could be wrong. We'll see. So ping 192.168.22.1, source 172.24.16.1. So of course this one's going to work. Everything in the same AS, I don't think there'll be a problem with. But where it could get interesting is Topeka, so we'll save the most interesting one for the end. But it looks like Miami's good. And it looks like Atlanta's good. So here's the one that might be interesting. Aha, so that looks good. So yeah, this might be all that is needed for every loopback to ping every other loopback. All right, let's try Jackson. Perfect. Oops. Perfect. Yeah, and this one is a lot more simple than, it's kind of the same as Memphis was in regards to its complexity. So these are going to be the more interesting ones. Yeah, and that looks good. Perfect. So AS604 is all good to go. So now here's where it might get really interesting. Can AS931 ping out to AS25? So we're going to figure that out by starting with Miami. And we'll ping all of these. I mean, we know that each of them were able to ping Miami. So of course, Miami is going to ping each of them, but just sometimes if I have the time, of course, if time is on the essence, then yeah, go ahead and manage it properly. But for me being in the lab, you know, getting that and we can even see here something is rotten in the state of Denmark. So I don't even have a route to this host. So let's see what is going on. So IBGP, that's good. So these looks like they haven't been modified. So I think I'm going to do that just to make it nice and pretty. I'm going to do it the correct way this time. Perfect. Excellent. And now just need to modify this. Perfect. So I've got everything ready to go. And of course, this is not going to make any changes. It's just going to be a little bit nicer to look at. I kind of paused there because I thought, oh, it's letting the wrong route into BGP. It should be 240, but that's the neighbor statement. It is 242 on the loopback. So I have a feeling that the issue is going to be in Atlanta. Well, let's before I go over to Atlanta, let's take a look and see if Miami is receiving any routes. So yeah, it's receiving. So we can see it's receiving only 3 routes. It's missing that route from Atlanta. So yeah, it just needs to be cleaned up. Just like here, it just needs this, and then it needs that to be modified. So I will go ahead and do that. So I'm going to delete this. Perfect. And then delete this. Perfect. And now delete everything in policy options. Excellent. And now I'm going to re-add that in now except it's going to be nice and clean. And I should be able to see very clearly which ones need to go in IBGP. And it's going to be 1, 2, 3, 4 routes. And then in EBGP, well, actually it's going to be 5 because it's going to include this one. But EBGP, well, those are the ones that need to go into to IBGP. To EBGP, it's only going to be 2 routes. So this is going to be flipped essentially, which makes sense because it's the other direction. So it's going to be the opposite. Okay, that seems good. So I'll start with, of course, this route just sits as a loopback. It's not a BGP route. It's a directly connected route, so it's going to be needed to be exported from the routing table into the BGP protocol. Oops. Oh, okay. That's just a notification from Snap Kitchen. Let's see here. Lost my train of thought. See what I'm doing? I'm putting my phone in silent mode. That might be my #1 most important tip that anyone watching this channel can learn. Yeah, it's kind of funny. I have a OnePlus, what is it even, like a OnePlus phone, and basically the only reason I decided to buy that one and was excited to buy that one versus any other phone is because it had a special button on it to put it into silent mode. And all I need to do if I wanted to go into silent mode is slide this thing down and slide it back up, and it's instantly, the whole phone is in silent mode. It doesn't vibrate, it doesn't make a noise, it just, there's a light that shows up, but I can put the phone the other way down and not see the light. I love it. All right, so 172.26.4.0/22. So yep, these are all the 5 routes that I need to, they're of course going to be going into IBGP. Okay, and then these are going to be going into EBGP. So yeah. Yep. And the ones going into EBGP is just going to be 2 routes. It's going to be the loopback directly connected route, and then the route learned over IBGP from Miami. All right, so that's perfect. Yeah. So now it's time to clean up Atlanta. The city has run amok. It's gotten completely out of hand. So I will be cleaning it up. Oh, and I need to check if I've got NetHop self as well. Oh, yep, I do. I've got it there. So, yeah. All right, so Atlanta is now cleaned up. It's kind of the pride of the USA now. Let's see here. Okay, so going back to Miami, hopefully now I can ping to Atlanta. Perfect. All right, so let's see if I can ping the rest of them. Perfect. Yeah, and as I mentioned before, there won't be any issue here because it was all pingable from there. But it's kind of a good kind of way to, it's kind of a good point about how BGP is kind of unlike any other protocol. I mean, the fact that I'm able to ping a route way here in another autonomous system, but I'm not able to ping this route in my own autonomous system kind of shows you just how different it can be. It's really not about discovering protocols necessarily, discovering routes necessarily. It's about sharing them. All right, so one final one. Oops, and yeah, this one has no route to host. So we're gonna need to check a number of routers. Let's start off by doing a trace route. Oops. Oh, right. So we've got no route to host. So let's do show route receiving protocol BGP, and then we know the neighbor. There's only one neighbor on this one. So we can see, sure enough, this is missing from here. So let's do a hidden. Maybe it's just hidden. Nope, it's just missing. So let's see if it's being advertised out of Topeka. So yep, it looks like it's being advertised just fine. Let's see if Atlanta is receiving that route. And for that matter, if it's advertising it. But let's first see if it's receiving it. Oh, and yep, it looks like it's only receiving 3 routes. Atlanta is. It's just receiving the routes from the autonomous system 604, and it's not even that it's invalid. It is just not receiving at all the route from AS25. It's only got those 3 routes. So yep. Oh, this looks, yeah, this is going to be a 4th route too because it's got its own, but it's not able to redistribute, or it's not able to send this route. So let's take a look at Memphis, at the routes being received and the routes being advertised. So yep, sure enough, it looks like this is not being advertised. Let's see if it's being received. Can I do hidden? No, I can't. Oh, I can, but I'm kind of wondering what the point of doing hidden is in this context. So let's see what I'm getting from Jackson. And I'm getting nothing from Jackson. Am I getting anything hidden? Getting nothing hidden. So I'm just not receiving anything from Jackson. What about from Biloxi? Oops, and this is going to be, so Biloxi, it looks like I'm just receiving its own prefix. So I'm really not receiving any routes except for the route from Biloxi, and it looks like I wasn't even receiving a route from Jackson. I don't know why I'm advertising it if I'm not receiving it. Yeah, because you can clearly see I'm receiving this route from Biloxi, but when I 10.2.2.1, oh, okay. So, oh, okay, that's interesting. So I wonder if I just put in the wrong IP address up here or something. Oh yeah, I did like 10.1.1.1 instead of 10.2.2.1. Okay, so yeah, I'm receiving, Memphis is receiving them. It's just not advertising them. So let's see, True Advertising Protocol BGP, 10.3.3.2. Yeah, so this is kind of what I expected to see, because this is a special situation. It's not just crossing one AS. It's going from 25 to 604 to 931. So you can see the other routes that aren't doing that are just going from one AS over to IBGP are not having any problem, but the route being learned from Jackson that was learned from Topeka, that one is not being advertised. So I'm wondering maybe if it needs to be imported. Let's just see what is special about this route versus the other routes that are being advertised. So detail. We'll see what's different about that route versus this route here. All right, and let's even do a side-by-side comparison. Perfect. So, yep, same number of lines. They're both 24 lines. Let's see what the differences are. So, looks like there are actually very few differences. I'm actually pretty surprised at just how few differences there are. I'm going to do a compare. Yeah, and you can see the only difference is, of course, the route itself, then the age and the metric. Of course, the age is going to be different, but even the metric matches. The announcement bits, that looks like that's quite a bit different. And the path is different. So let me bookmark these lines, because these are where all the differences are. And then I'll clear the compare. So we can see there's, aha, so here we go. The AS path is different. The announcement bits are different. This one has 0 KRT, but it has 1 BGP RT background on it, whereas this one does not. This one has 2 resolve tree, 1, and 0 KRT, but it does not have this special announcement bit. So I think a good start is to just learn about what that is, because that looks like it's the main difference between these two routes, is that the route from the AS has, of course, a different AS path. It only came from from internal, the same AS this is in, whereas this one started in 25 and then went into internal, and then as probably relating to that, it's missing this announcement bit here. So maybe something about that announcement bit has to do with why it's not advertising that one when it's advertising the other one. Aha, here we go. Why is BGP route not advertised? This looks like it's the exact answer that we're looking for. I wish it would open up. It looks like it's not going to. It's thinking about it. It's kind of slow. I don't know why it's so slow to open. It's always frustrating when you have the perfect answer, but it just won't load. Okay, there may be, well, let's go right to where this showed up. Oh, it looks like it didn't show up. Ah, here it is. So it looks like they're not talking about it specifically. Yeah. Unfortunately, okay, so I think my order's here, but I just want to log off at 7. So then they just leave it at the door. But let's keep looking into this issue here. Okay, so none of this documentation actually appears to be relevant, which is kind of too bad. I wish there were more about this specifically. And it looks like my internet is not having a good time again. I mean, Friday at 6:50, it's probably just a lot of other people are using it. Yeah, I've got like I've got like 3. Oh my God! Wow. Yeah, it's probably just a lot of people using it because it's Friday night. I've even got more upload than I got download now. People watching Netflix and stuff. Well, that's too bad, but it hasn't stopped me. Don't be alarmed about the fictitious next hop bit. It's an extract from the use of BGP, which has a property for next hops versus a flow spec, which has no such need. Okay, well, I wasn't alarmed by that. I'm alarmed by this extra thing. So Junos OS does not advertise the routes learned from one eBGP peer back into the same external BGP eBGP peer. In addition, the software does not advertise those routes back into any eBGP peers that are in the same autonomous system, AS, as the originating peer, regardless of the routing instance. You can modify this behavior by including the advertised peer AS statement in the configuration. If you include the advertised peer AS statement in the configuration, BGP advertises the route regardless of this check. To restore the default behavior, include the no advertised peer AS statement in the configuration. The route suppression default behavior is disabled if the AS override statement is included in the configuration. If you include both the AS override and the no advertise peer AS statements in the configuration, the no advertise peer AS statement is ignored. Okay. So yeah, it doesn't quite make sense to me. I think this is the right documentation to be looking at, though. So let's see here. Oh, that's all there is about BGP. I think this might be, let's see here. Junos does not advertise the routes learned from one EBGP peer back into the same BGP, EBGP peer. Well, I mean, that doesn't seem like it matters that much because we don't want it to do it back into the same peer. We want it to go to a different AS. So let's just learn more about these two commands because they could be relevant. Description: compare the AS path of an incoming advertised route with the AS number of the BGP peer under the group and replace all occurrences of the peer AS number in the AS path with its own AS number before advertising the route to the peer. The AS override statement is specific to a particular BGP group. This statement does not affect peers from the same AS configured in different groups. Okay, so this actually might work. I don't know if this is the way it's meant to be done. Enabling the AS override feature allows routes originating from an AS to be accepted by a router residing in the same AS. Without AS override enabled, the routing device refuses the route advertisement once the AS path shows that the route originated from its own AS. This is done by default to prevent route loops. The AS override statement overrides this default behavior. Note that enabling the AS override feature may result in routing loops. Use this feature only for specific applications that require this type of behavior and in situations with strict network control. One application is the IGP protocol between provider edge routing device and the customer edge routing device in a virtual private network. So yeah, that's kind of what I thought. Like this is, like it'll work, but it's really dangerous and it's not, if I do that on the test, I'm probably gonna lose points. So let's see here. Or even worse, I could cause a routing loop and the whole thing crashes and it takes an hour for the test proctor to even get back up online. Okay. All routing protocols use the Junos OS routing table to store the routes that they learn and to determine which routes they should advertise in their protocol packets. Routing policy allows you to control which routes the routing protocols store in and retrieve from the routing table. For information about routing policy, see routing policies, firewall filters, and traffic policer's user guide, which is where we just came from. Where are we now? So right now we're in the BGP user guide. That sounds like a much better place. All right, so when configuring routing policy, you can perform the following tasks. Applying route policy. So Just kind of want to get to the point here. This looks interesting. Oh, it's on a route reflector. Yeah, so I guess, yeah, so this is kind of interesting. I wonder if I'm going to need to import this. Let's take a look closer at Memphis. And we can see we're still working on Miami right now. And the problem is that Memphis is receiving the route .4.0, but it's not advertising. Oops, and this is to let's see here, 10.3.3.2. So yeah, it's receiving it from here, but it's not advertising it. So that's interesting. Why is it not advertising it? So that's what I need to figure out. And let's see if that is even in the table, because if it's not in the table, then we know from what we've read earlier that I'll just need to create an import policy to add it to the table before it can be exported. But we can see it is in the table, so I wonder if it's just not included in the exports. Aha, so it looks like we've got, yeah, it's just not included in, oh, yeah, it's just not included in the exports. So it looks like I just forgot to include that in there. So unfortunately, it's kind of an easy fix. I was hoping to really learn something kind of deep about BGP, but all I learned is that I kind of will need a good strategy for not forgetting things and making simple mistakes when I take the test, which I already knew. All right. There we go. So now, hopefully, Miami is going to be able to have a much better time. And I believe I pinged all of them. If I did, it will be in my buffer, and it'll be easy to just go back and do it again. So here's the first ping. So that's to Atlanta, which is good. So here's the second ping, which is to Memphis. It's good, and I'll skip all those because I know if they were able to ping me, I'm able to ping them. But let's see about Topeka. Perfect, so Topeka's good now. All I needed to do was fix that mistake I had on Memphis where I wasn't exporting the Topeka route. So I'm just gonna do another quick victory lap just because it feels good. And I'll just ping all of them. So Atlanta's good. Memphis is good. Biloxi is good. Jackson is good. And we just ping Topeka, but this is going to be the victory ping. Victory. So while that's still pinging, I'll cross off Miami. And now we just got 2 left before moving on to the next exercise. And off of this diversion, I thought this was a very valuable diversion. I learned a lot more about BGP import-export policies. I discovered the next hop self, why that's so important on IBGP. I just think I learned more about what I'll need to know for the test, just kind of going off the rails and exploring and being curious than following an exercise. So yeah, I think it took a lot of time, and of course time is going to be my most valuable asset, really, and if I don't manage it properly, I will not be able to pass the test. But that's why the most important thing is just getting as much value for my time as I can, which I think I've gotten a lot of value out of the time I've spent on this extra exercise. Okay, so that looks good. Looks good. And of course, this is the same deal. If I could ping to it from everyone, I could ping from it to everyone, because a ping is two-way. If I open up the packet sniffer, you'll see when I do a ICMP, you'll see them from 2 different source addresses. You'll see them for the reply. Perfect. So last one, and we were able to ping it from everywhere else. So we already know that it works, but I'll just take a final victory lap, and then I'll take a final look at all of the configuration, and then I'll throw it all to the wind, to the dust, and move on to the next exercise. Now that I spent all this time, blood, sweat, and tears to set it up, I'm just gonna break it down. Okay, so that looks good. And that looks good. And that looks good. I mean, we know they're all going to be good. It's just, I kind of like to feel good about having done this. And this is kind of a way I can do that. Just going and confirming that they all work. Okay, so let's do one final run through all of the routers. First thing I'm going to do is just print out all the configuration, and you can see this one, all we've got is one EBGP connection, and then of course we're going to need to export some routes into the BGP protocol from the routing table. So the route we've got in the routing table is going to be a directly connected route here. So I made a route filter for that. That includes that exact route. And I made a policy statement where if it's in that route filter, then I'm going to accept it. If not, I'm going to reject it. So then I exported it into EBGP. So if I do show route advertising protocol, BGP 10.1.1.1, you can see I'm sending it out. And then by merit of my configuration on the other side, you can see, oops, oh, there's, God damn it. I wish they would call it receiving protocol and advertising protocol instead of advertising protocol and receive protocol. Okay. But you can see I'm receiving 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. And oh, is it just 5? Yeah, it's just 5. And now you can see too, here's the paths. So I didn't need to do any special configuration to allow these routes. I just need to fix an error I had on Memphis. So yeah, that's really easy. Let's take one look at the routing table. Maybe they're of a different metric, because let's see how any of the extra information changes. So this is just got I and 604, but this has an additional one. But we can see that the same local preference, same administrative distance. So let's take another closer look into the difference between these two. Okay, so local AS, peer AS, unverified task. So these announcement bits are interesting. It looks like they're the same. So yeah, the only difference is just that AS path. All right, so that's interesting. We can now take a look at Jackson. There's really not going to be anything all that different. I think just the deep dive into Topeka is the main thing, but just because I spent so much time on it, I want to make sure I give it its due before I tear it down. But we can see on Jackson, we're going to need both EBGP and IBGP. So for EBGP, we're going to be exporting 1, 2, 3, 4, 5 routes. So we've got extensive that, but IBGP, we're going to be exporting 2. And you can see the direct route, we've got to export into both EBGP and IBGP. And the other thing to note is we're only exporting. We don't need to import, because to import, you take a route from a routing protocol and you put it into the routing table. But to export, you take a route from the routing table and you put it into the routing protocol. So the only reason you would want to use an import is because a route did not make it from a routing protocol to the routing table. There's a process by which they are added to them automatically, but if you wanted to override that process, or you wanted to take a special route that's not in the table already, but it is through a protocol, you can import it that way. But import is to move a route from a routing protocol into a routing table, and a reason you could do that is to usurp or to add an extra route that didn't make it in there from the routing table because it wasn't selected as the best route or something like that. And then export is to move a route from a routing table to a routing protocol. And that's primarily what is required, is exporting routes. Importing routes is going to be a lot more rare. All right, so yep, so we can see I used a route filter, and then IBGP only needed 2. The other thing we learned about is this next hop self. So when a route is exchanged through EBGP, it will update its next hop. But when it's exchanged through IBGP, it will not update the next hop. It will send the route as it received the route. So from Topeka, if I were to receive a route in Jackson, and I can do that, show route, receive protocol BGP.2. So the next hop is going to be 10.1.1.2 for that. And I'm kind of surprised it's not, well, so it's good. I wonder if Topeka has next hop self set up, actually. I'm kind of curious about that. And I'm kind of curious what would happen if I remove it, which of course I can do. That's the great thing about the lab and about it being the after work video. I have more time. So yep, sure enough, there's no next hop policy. So yep, that's how the route is shipped. It's shipped with this next hop like this. But the thing is, in Biloxi, it would receive the route with the next hop just like this as well. But that's only if I did not modify it through the next hop self. So one thing I can do is I can show route advertising protocol, BGP, 10.10.1.1. Oops, and yeah, I'm actually not advertising any over there. It's learning it through the other. There we go. So yeah, it's learning, Biloxi is learning Topeka like this. I'm not sure why it's doing that, but this video is going quite a bit long, so we won't be able to dive into that. So yeah, so we can see next hop self, but if I were to remove that policy, which I'll do. So edit protocol BGP group IBGP, show pipe display set relative. Now if I were to remove this export, oops, it's not letting me hit enter. There we go. See, there's like this weird delay. Sometimes it's tough. Sometimes life is hard. But yeah, now you can see the next hop is still self for this one, but that's because it was originally had the next hop as self. It was a local route. But here, the next hop, does that look familiar? Yep, it's the same next hop that Jackson had when it learned from Topeka. It did not modify it after advertising it to the next neighbor. So that's obviously going to be a big problem, and that's why that next hop self policy is necessary, so that it modifies that next hop so that it's usable by the BGP neighbor who receives the advertisement. So back to self. All right, let's move on to Biloxi. Maybe we can even figure out, it might be interesting to learn why it's learning 72.26.4.0 from Memphis and not from Jackson, because 1, 2, you know, instead of 1, 2, 3, why is it taking that extra hop? It could be because it's got better metrics, because these two are aggregated Ethernets, but I actually don't know why, so I will reserve my intuitions. Okay, so Biloxi, aha, and it looks like Biloxi was never updated to have the kind of nicer configuration. So that's probably a reason right there why it's learning it through Memphis and not through Jackson, because it's not the route filter is now up to date. So show route receive protocol, or let's do a show BGP summary, show route receive protocol BGP 10.10.1.2. Okay, so from 10.10.1.2, which is up here, yep, you can see it's receiving, oh, it's actually not receiving the .4. I'm surprised. I mean, we did do the ping and saw that everything pinged everything else, so oh, it is, well, that's really interesting, because it looks like Jackson wasn't advertising it to Biloxi, but Biloxi is receiving it from Jackson somehow. That doesn't make sense. So it's obviously a problem there. So advertising protocol to 10.10.2.1. Oh, okay, it is. So yeah, I don't know. I mean, maybe I was making a typo, or maybe I just didn't know. Oh yeah, I was doing .2 instead of .1, I think. Yeah, yeah, you can see 10.10.2.1. Or if I was doing .2, yeah, I wouldn't get anything if I was doing .2. So I was probably just accidentally doing .2. But yeah, it's advertising it to Biloxi. Biloxi looks good. And that whole issue of it taking that extra path here, that's just not true. I was just confused. In fact, I can even do a trace route to 172.26.4.1, source 192.168.22.1, and there'll be 2 hops. Yep, 2 hops, perfect. All right, so let's go to Memphis and take a look at that. All right, and really nothing new here. It's going to be a more complex config, just like Jackson. So we've got IBGP and we've got EBGP. We've got route filter lists that include all of the EBGP routes, which are going to be just 2 learned from this AS, and then of course its own direct route. So we're just going to have, let's see here, this is Memphis. Oh, okay. So the routes that we're going to advertise into EBGP, we're going to have 4: Topeka, Jackson, Biloxi, and then Memphis. So yeah, 4. And then the ones we're going to advertise into IBGP, that's where we're going to have 3, because we've got to advertise everything in AS931 and then the loopback on Memphis as well. So yep, that looks perfect. Everything looks good. Really nothing more to talk about that hasn't already been talked about. Let's take a look at the advertising protocol, or what's being advertised out to the neighbors. So show BGP summary, show route advertising protocol BGP 10.2.2.1. So what's being advertised to Jackson? It looks like all 3 routes are being advertised to Jackson. Let's see what's being advertised to Biloxi. So yep, same 3 routes are being advertised to Biloxi, really good. So what's being advertised to Atlanta? Perfect, those 4 routes. So yeah, everything looks good. And then we can notice the AS paths, so we can tell immediately these are the ones being advertised to Jackson, but we can guess which ones are from Miami or which one are from, yeah. So we can see which one's the loopback on, because that one's I. And then likewise, same here. And then here, the ones that are out there, we see which one belongs to Topeka, because that's the AS path 2.5. All right, so that's, I think, all there is. Well, let's look at the receiving protocol as well. BGP, and let's see what we're receiving from Atlanta. So we're receiving 2 routes, the AS path, and let's see what we're receiving from each of those other neighbors. So 10.10.1.1, what are we receiving from them? We're just receiving the 1 route, but from 2.2, we're going to be receiving EBGP routes as well. So we're going to get 2 routes, and you notice one, it's a EBGP route, originated in AS25, and then the other one's just the IBGP route. Okay, so yeah, real easy, straightforward stuff. So I'll just kind of look over Atlanta and Miami as well. I think those are going to go a bit faster, and then I'll end the video, and the next video will be the next exercise in the Juniper documentation. Kind of sorry to see this one go. It was, I think, a lot of fun. So yep, we've got the next hop self, same thing as before. Got the routes being advertised, so lots of routes going into EBGP because it's having all of these. Then all of the, oh, I forgot to cross out the last one. Yep, and then the other way around, we've just got 2. So real skimpy in the EBGP, lots of routes in the IBGP. Then we need the next hop self, of course, so show route advertising protocol BGP, or let's do a show, well, they're all listed, show route advertising protocol BGP 10.3.3.1. So next hop self, very good. And that's where, since these are going into EBGP, it's still going to be next hop self. But if the one's going into IBGP, so advertising protocol 10.240.10.1 to this neighbor, these are all the ones in IBGP, we're going to see all sorts of crazy changes here if I get rid of that next hop self configuration, which I'm going to do right now. So group IBGP, show pipe display set relative, delete, export, next hop self. So now we're going to see those next hops go all haywire. Yep. So you can see that's really not going to work for Miami. It'll be fine for Atlanta because it'll be able to use this next hop, but Miami has no knowledge of this next hop, so it's really not going to be able to install that route. It'll have to have knowledge of a usable next hop, which is what that policy will do. And if see, of course, the loopback, the only one that was learned in AS 931, that's already has next hop self. And you can see, I bet you if I even roll it back on Memphis, these will even change. Well, these will disappear if I roll it back on Memphis, but let's see what happens if I do that, because that might be interesting. So what I'm thinking will happen is a lot of these routes will disappear, but let's see what happens. So configure private, edit, BGP protocol, BGP group, and then it's going to be EBGP, show pipe display set relative, and now delete, export into EBGP, commit. So now I'm thinking, yep, so one disappeared. It looks like we only lost one, which is interesting, but I bet you it's going to be this Topeka one here is the only one that was lost. So it's the .4. Oh, no, it's not the Topeka one. So which one was even lost? That's interesting. So we've got 22.0, we've got 0.0, we've got so it looks like the loopback one was lost. That's interesting that that was the only one that was completely lost, but it yeah, huh, that's interesting. But we'll see it pop back up. 10.24, there it is. So when I don't have a policy of next hop self on Memphis, Atlanta doesn't learn about the loopback address on Atlantis for EBGP. So that's really interesting, I think. So I'm going to roll back that on Atlanta, and then I'm going to move over to Miami. And that will be the last router. So everything's pretty simple and straightforward on here. show routes, advertising protocol, BGP, and then 10.240.10.2. So yep, it looks really nice and easy. We don't need a next hop self on this one because it's got the correct, it's going to be modifying it here. So let's look at receiving protocol or receive protocol. Perfect. So yeah, so now they've all got this next hop. So let's see what happens when I remove that from the router where that next hop is configured, which is Atlanta. So they all disappear. The only one that remains is the one from Atlanta, and that's because they all have the wrong next hop. So if I were to do hidden, you see they're all still there. It's just they can't use this next hop 3.3.1. That makes no sense. It does not have a route for 3.3.1. If I do a show route on that, there's nothing there. So it's not going to work. But if I roll back that change, these will all pop back in and everything is good to go. And we can very clearly see which one is from Topeka because of the AS path. And we can see that yeah, kind of interesting that it looks like it's almost out of order, this I. Oh, okay, so I think it's just saying that the route traveled through 604, traveled through 2.5, but originated in 2.5. So this just means where the route originated. Okay, so I think that's it. This was a complete success. I was able to get all the routers pinging one another. I learned about the next hop self policy. I learned about BGP exports. I learned about route filters. I learned a lot of really good stuff. I learned how to configure port channels, got more comfortable with that. So lots of great stuff in this series, but unfortunately it is time to move on to the next one. I can't spend too much time on any one topic. So I'll see you in the next exercise.